Welcome to Deep Dive Defense, military and aerospace enthusiasts. Over here we give rare insights you won't hear elsewhere. Today's video focuses on the Bavar-373, Iran's advanced long-range surface-to-air missile system developed in accordance with the requirements of the Iranian Air Defense Force. The cancellation of the contract for the delivery of the S-300 SAM system by Russia in the mid-2000s was a significant setback for Iran's air defense planning. At that time, Iran only had limited quantities and capabilities in form of legacy long-range surface-to-air missiles, such as the S-200. In contrast, the S-300 offered ballistic missile defense capabilities, a feature that Iran's existing systems lacked. In response to this setback, Iran demonstrated its intention to develop a comparable long-range heavy SAM system by showcasing mock-ups of an S-300 lookalike SAM system during the 2010 Army Day parade. The components, modeled after the S-300, were mounted on the Bavar-400 off-road capable heavy-duty truck. The Soviet S-300 SAM system, with its extensive high-end requirements, was highly complex, and Iran aimed for its Bavar-373 to meet similar standards. The interceptor missile was envisioned to be a heavy missile, with a diameter of approximately 515 millimeters. It was also designed with the ability to feature a 5-minute shoot-and-scoot mobility, even in challenging terrain. In addition, the system had to be able to intercept targets at very low altitudes, high altitudes, and ballistic missiles re-entering from space. By the early 2010s, Iran had already mastered several key technologies necessary for a system like the S-300. Iran's solid propellant rocket motor technology was sufficiently advanced to support the development of a booster motor that could meet the required size and performance, allowing the creation of a Mach 6+ interceptor missile. Furthermore, previous projects such as the Bavar-400 tank carrier and the Zafar heavy-duty off-road truck provided a solid foundation for developing a suitable platform for off-road mobility. In the field of radar technology, Iran had developed the Najm 802A radar for the IRGC Aerospace Force's Sayyad-2 SAM system, an S-band active electronically steered array. By 2014, 4 years after its announcement, the first images of the Bavar-373 were published. The missile interceptor, designated Sayyad-4A, had reached its final design, benefiting from Iran's strengths in missile technology and successful SAM system projects. The Sayyad-4A differed from the S-300 missile in two key ways. Firstly, it lacked a jet vane thrust vector control system, which would have allowed it to immediately alter its trajectory after the vertical launch to engage targets at both high and low altitudes. The thrust vector control system also had the potential to be used during the initial boost phase, which lasts between 8 and 20 seconds, depending on the motor design. A missile with such a system would have had significantly increased maneuverability at ranges of 10 to 20 kilometers, particularly against ballistic missile targets intercepted at high altitudes, where air density is lower. To compensate for the absence of a thrust vectoring system, strakes were added in front of the rear steering fins, improving the missile's steering performance in the thinner upper air layers. The Sayyad-4 missile, like the Sayyad-3 missile used in the Talash SAM system, focused on intercepting medium and high-altitude targets, thus neglecting high-performance low-altitude interception. This made sense given that the Bavar-373 was designed to be a part of a multi-layered integrated air defense system, with other systems handling low-altitude threats, such as cruise missiles. The radar systems displayed with the Bavar-373 were notably different from the passive electronically steered phased array radars seen with the S-300 and Patriot systems. This suggests that Iran had selected an AESA design for both the acquisition and engagement radars. The technology used for the Najm 802 radar helped in creating the S-band AESA acquisition radar, but the X-band engagement radar was a different challenge. In order to match the S-300 U-2's range of 200 kilometers, Iran needed to develop an array large enough to track and engage smaller targets, like fighter jets at that range. This required thousands of high-power X-band transceiver modules. Establishing a mass production line capable of producing these modules in large quantities was a challenging task. However, by 2016, following the geopolitical shifts that affected Russia's relations with the West, the S-300 U-2 systems were finally delivered, just as the Bavar-373 was nearing completion. In 2017, 7 years after the Bavar-373's development was announced, a working prototype was unveiled. This version featured a 5-axle off-road truck called Zoljana, which carried 4 Sayyad-4 missiles in hot launch containers. The truck had a gap between the 2 sets of missile containers to vent the hot gases during vertical launch. The S-300P series used a cold launch method, which ejected the missile from a tube before igniting the motor. But Iran opted for a hot launch method. The hot launch system had a reduced risk of igniting surrounding vegetation due to Iran's dry climate, and it simplified the system by eliminating the gas ejection system. No gas generator and mechanically robust launch tube were hence needed to be developed. This decision to go with a hot launch made it similar to Taiwan's Tiancong-3 long-range SAM system, based on the Patriot. The next new component revealed was the integration of the Mirage 4 S-band volume search radar, which was designed for a role similar to the NATO codenamed Big Bird radar used in the S-300P system. Unlike the Big Bird, which used a 2-faced design, the Mirage 4 had a single array, offering somewhat reduced situational awareness, but it still provided sufficient early warning at extended ranges. The 2017 unveiling of the Bavar-373 also marked the first time the acquisition and engagement radars were shown in their almost final form. While the Bavar-373 was still a prototype, the IRGC Aerospace Force's third Cordad SAM system, which used an X-band AESA array with transceiver modules, similar to those needed for the Bavar-373 engagement radar, was already in production. Continuous improvements in the X-band transceiver module technology were focused on achieving a high-power output for the Bavar-373's serial production. The 2017 Bavar-373 prototype was the first to undergo field testing, including tests against ballistic missile-type targets such as the Zulfiqar short-range ballistic missile. In 2019, 9 years after the Bavar-373's announcement, an improved version was revealed. This new version, which included large identify friend or foe secondary arrays on the acquisition and engagement radars, was designed for service acceptance testing by the Air Defense Force. This version also introduced the Sayyad-4B missile, a heavily redesigned missile featuring a jet vane thrust vector control system. This system was similar to the one used in the latest S-300PMU-2 and S-400 missiles, allowing for an instant trajectory alignment against low-altitude cruise missiles. The thrust vectoring system prevented energy from being wasted on less efficient lofted trajectories, enabling a more direct interception. The addition of this technology may have greatly enhanced the Bavar-373's ballistic missile defense capabilities by making it more effective against maneuvering ballistic missile targets. The Sayyad-4B missile is believed to be capable of engaging ballistic missile targets at ranges of 10 to 20 kilometers and altitudes of 27 kilometers and higher, well beyond the capability of the older Sayyad-4A missile. The Sayyad-4B missile also featured reshaped strakes placed in front of the rear steering fins, which contributed to better aerodynamic performance. The AD-200 export version of the Bavar-373, which is believed to be based on this improved configuration, has an engagement radar capable of engaging targets at 200 kilometers, the same range as the older Sayyad-4A missile. With the appearance of the Russian S-400 system, which has a missile capable of reaching ranges of up to 380 kilometers by flying a high apogee trajectory and using an active radar seeker, Iran was incentivized to further enhance the Bavar-373's performance. The Bavar-373's engagement radar array is smaller than that of the S-300PMU-2 and S-400 systems, but it reportedly supports multiple beamform tracks for up to 6 targets. This allows for simultaneous engagement, which is a key feature of modern SAM systems. However, to maintain this capability at extreme ranges beyond 200 kilometers, Iran needed to make further improvements. Though Iran had mastered the production of active radar homing seekers by the mid-2010s, the Bavar-373 was required to retain the semi-active radar homing seeker used in the S-300PMU-2's seeker-aided ground guidance system. This system integrates data from various sensors, including the S-band acquisition radar in continuous scan mode, and the X-band engagement radar. The radar signature of the target being detected by the missile's seeker is also fused into the system. This combination of sensors improves the system's resilience against electronic warfare techniques, enhancing the effectiveness of the Bavar-373. To extend the range of the Bavar-373 beyond 300 kilometers, on par with the S-400 system, a new radar component capable of illuminating targets at such distances was required. The latest variant of the Bavar-373, briefly revealed in 2019, incorporates a new Transporter Erector Vehicle, TEL, with 4 axles. This version also includes a mast-mounted emitter, similar to those found on the S-300V series and the Russian S-500 and Abakan missile defense systems. An improved variant of the Talash SAM system's OFOG illuminator without a receiver and tracking capability is used. Once the system receives target tracks from the S-band acquisition radar, the illuminator directs continuous wave radar energy at the target, allowing the Sayad-4 missile seeker to lock onto the reflected energy and home in on the target. This additional illumination antenna also increases the number of available channels for the battery, as each illuminator paired with the S-band acquisition radar adds another guidance channel to the system. With the X-band engagement radar able to support intercepts at up to 200 kilometers, the addition of 3 to 6 illuminators on the tails of a Bavar-373 battery increases the number of target channels from 6 to 12. This setup allows the battery to extend its engagement azimuth beyond the approximately 90 degrees covered by the engagement radar, adding another 90 degrees of coverage provided by the S-band acquisition radar and the tail-mounted illuminators. This expanded coverage improves the ability to counter sneak attacks from the rear, while the 360-degree rotating Mirage 4 radar enhances the situational awareness of the battery. Additionally, the mast-mounted illuminators improve the battery's continued operation in case some components are disabled. A long-range thermal camera may be mounted on the mast in the future. Such a thermal camera would enable angular tracking, allowing the illuminator to be oriented toward the target. This means each TEL could potentially engage targets even if the acquisition and engagement radars are disabled, relying solely on the Mirage 4 volume search radar as the remaining intact early warning sensor. A thermal camera would also provide a secondary identification friend or foe (IFF) capability, helping to exclude small decoys or countering electronic warfare interference. In 2022, the Bavar-373's latest variant reportedly intercepted a target drone at a range of 320 kilometers, coinciding with the debut of a production line for the Sayad-4B missile. The inclusion of the mast-mounted illuminator in this variant of the Bavar-373 suggests it has now been accepted into service by the Air Defense Force, more than 10 years after the system's initial announcement, a typical timeline for such complex industrial project. The Bavar-373 TELAR and its illuminator have been integrated with the S-300PMU-2 systems and potentially even S-200 sites that have been upgraded to the Talash 3 standard. The Sayad-4A and Sayad-4B missiles are reported to have a backup active radar homing mode, which activates when the seeker-aided ground guidance system cannot function, such as when a target dives below the line of sight of the ground radar. In such situations, the missile can switch to active radar homing and continue tracking the target. This capability is crucial for maintaining the system's lethality and robustness, ensuring it can switch guidance modes when one system is compromised by electronic warfare. In 2025, photos released from a Sayad-4B launch apparently show an added infrared seeker, similar to that of the US SM-2 Block 3B. This would further improve the guidance robustness of the system by creating a hybrid radar-infrared seeker combination. In conclusion, the Bavar-373 fulfills its role as a heavy long-range SAM system with significant robustness and lethality, comparable to the S-300PMU-2. With its final variant shown in 2025, it surpasses even the S-300's performance, approaching the capabilities of the S-400, especially in terms of extended range and the improvements brought by the Sayad-4B variant for ballistic missile defense. The system's ability to counter very low radar cross-section (RCS) targets, such as the F-35 stealth fighter, is addressed by avoiding X-band target tracking at extended ranges. Radar-absorbing materials and shaping techniques lose some of their effectiveness in the S-band. The use of high-power large S-band AESA acquisition and volume search radars facilitates detection at extended ranges. The X-band illuminator, while not tracking the target directly, emits continuous wave radar energy at it. It is cued towards the target via 3DS or VHF band radars, or even thermal cameras doing angular tracking. The Bavar-373 achieves the goal of being a multi-role long-range SAM system. It can engage cruise missiles, interdictor fighter-bomber targets utilizing terrain masking at extended ranges, address medium, and high-altitude targets like stealth F-35s at ranges of 200 to 300 kilometers, and intercept maneuvering ballistic missiles at ranges between 20 to 40 kilometers. This broad capability demonstrates why the Bavar-373 is poised to form the high-end backbone of Iran's Air Defense Force SAM systems. It is believed to have entered serial production at this point, with a slightly different Tealer vehicle shown in 2025 believed to be the final production version. So that's all for today. If you liked it, give a thumbs up, comment, and subscribe. It really makes a difference in the YouTube algorithm and is a great support to the channel. The real enthusiast can become members and given access to exciting membership area material. Thanks for your support and motivation. See you next time.